couldn't get the video output to work. Usually I like giving demos. I always hope that the demo will work. So we're going to give it a go. Instead of doing it at the end of the presentation, I'll do it at the very beginning. So I haven't lost your attention yet. If I do it at the end, you might be already halfway asleep, So I'll show the demo at the very beginning. So, probably, I think it was 1 or 2 years ago, I was researching access IP cameras, and I found some cool stuff. One of the vulnerabilities that I like the best is it's a persistent cross-scripting on the logs page. So if you log in as administrator to access IP cameras, typically you have a logs feature, right? So you can see what kind of HTTP requests are being sent to the IP camera. I'll just show you so you know what it looks like. So that's the logs page, and as you can see, it just basically will tell you, look, there's been a GET request made at a certain time. The usual stuff, just like the same kind of stuff you will see on Apache HTTP server, right? So it turns out that you, as the attacker, you can send a malformed HTTP request, which will inject anything on the logs page. So the requirement for the vulnerability to be exploited successfully is that the administrator must check the logs page at some point. This is the requirement. So it's not, you cannot own the camera code. There's user interaction required. So, how the administrator would be tricked to check the logs page, well, we don't know. Perhaps he will do it for, because he's actually doing what he's supposed to. He's checking the logs. Perhaps he's been social engineered to check the logs page. Either way, if you check the logs page, the camera can be completely compromised. In the paper that I wrote some time ago, I developed 3 different payloads. One of them adds a new administrator account, so the attacker can get back via the new administrator username. The second payload steals the passwd file and sends it to the attacker. So all you do is you can use XML HTTP request AJAX function to scrape a certain URL, which will allow you to retrieve the contents of any file. Access IP cameras use very old school, the old school passwd file, which means that you don't need the shadow file to crack the passwords. This is like old school stuff, okay? That's the kind of thing that many of these IP cameras use. So a few months ago, I just wrote a little tool, and the idea is to show the third payload, which I discussed in the paper, which is, you hijack the video page. So, I just wanted to do what they show sometimes in Hollywood movies. You have the usual attack in which someone has compromised a CCTV system, and the attacker has put a video which looks the same as the legitimate one, but it's looping. So you get like 4 seconds looping back and forth. Now, in this case, I wasn't elaborate, so I didn't come here, get a real video, and then make a loop. In this case, I'm showing something that will make it extremely obvious that the video has been changed. It's a defacement. It's an animated defacement. If you want to go elegant, what you do is that, I would record, in this case, a small video clip, then I will convert it to Flash, and then with the defacer tool, we will inject the Flash file. So from that point on, after the video is injected, even if you have people walking in front of the camera, you're just not going to see it because you're going to have the same video looping all the time. So if you give me a second, I just have the command in a TXT file. This tool is publicly available. If you like playing with access IP cameras, you can go to eBay. They're very cheap, they're very fun to play with. So it doesn't necessarily mean you have to spend a lot of money, to research them. So this is just a command. Okay, in this case, all it is, I'll describe it now. Let me paste it. So, of course, that's the IP address of the camera, 0.100, right? And then if you look at the options, you have different types of defacement that are implemented. The URL, in this case, is localhost. In reality, you would give the URL, which would correspond to a website, some random third-party site, which is hosting your video or animated GIF, whatever you want to inject. I mean, that you could put it on googlepages.com. Any free hosting provider will do. In this case, the file that I'm injecting is an animated GIF, and it's stored, it's hosted locally. That's why we're using localhost. So in theory, if it worked, the malform request has already been sent, and at this point has been logged. So let's say that I'm the administrator, and because I'm actually doing what I'm supposed to, I'm checking the logs on a regular basis, right? So literally, I'm just going to do control refresh because I'm already on the logs page. Control F5, sorry. So in theory, the payload has been injected. If we look all the way down, here you can see basically what I'm doing. I'm forging 2 requests. The first one, if you look at the URL here, all it's doing is changing the title of the page. If you remember before, in the video page, you will have the title on the top, and then you will have the video. What you can do is that you send in the injected payload, you cause your browser to change the title of that video page. And in there, basically, all I'm doing is I'm injecting my own content, and then I'm putting comments, HTML comments, so the real video doesn't show up. The second request that's forged, it's a reboot request. I don't even know if I can see it myself. Blah, blah, blah. Yeah, here it is. Do reboot. You see, this is the URL. So I'm rebooting the camera. Why am I rebooting the camera as well? Because access IP cameras, after they're rebooted, the logs are cleared. So you want to compromise the camera, and you also want to hide your tracks. So in theory, if it worked, when I go back to the video viewing page, there should be, there you go. So we changed the original video with our own. And of course, this is just, as I said, it's a very obvious defacement. In reality, you would inject a Flash file which looks like the legitimate video. So that's just a little demo, It's just something to get your attention, The presentation itself, there's a lot of slides, right? And I'm not going to go through all of them. The reason why I put a lot of slides is because sometimes people, they're interested in researching the topic further, right? So I have links all over the slides. If there's anything you're interested in, the slides will be online. Click on the link. You have further references. So in a way, it's kind of like slides/reference book, if you will. So very quickly about me, I'm just a security monkey like most of you. I like playing with stuff. I do research. I do penetration testing. Sometimes for fun, sometimes for a living. Pen testing, always for a living. Research, sometimes just for fun, not necessarily commercial. And I'm mainly involved with 2 organizations, which are GNU Citizen and ProCheckup. So this is basically what we're going to go through. In short, I will discuss why I like the idea of researching embedded devices, right? What kind of issues I have discovered, and some final thoughts on the current state of embedded devices security. So the main drive behind this research is that although obviously some people choose to research embedded devices, if you compare embedded devices to general purpose desktop operating systems or regular server operating systems, people don't seem to poke with them as much. And the reason for that is because you look at it and you think, this is just a little crappy device. Who cares if it's compromised? Who cares if my HP printer gets compromised? Even if it's internet facing, what are you going to do? Cancel the print jobs? No one really cares. So because we all have this mentality, people don't really think it's interesting to research them, And the main things that I research are universal plug and play, SNMP, HTTP, and so on. It all comes down to the same thing. If you look at most of the stuff included in the slides, you'll see that if you target an embedded device via the web console, it's so much easier to compromise it, as opposed to any other methods. A few months ago, we organized a router hacking challenge on GNUCitizen.org, and there were some really cool vulnerabilities, that some guys have found. And the pattern is that, about 90% of the serious vulnerabilities, they were targeting the web console, So if you're into web security, you'll see that embedded devices is kind of like doing a web application penetration test in 1997. There's some very simple mistakes that you just don't think that they will be there. Especially when it comes to authentication bypass bugs and that kind of stuff. I research both home and commercial products or corporate products, if you will. And really, all these attacks, they can be categorized into under two different labels. You have the typical old school classic cold ownage attack. So you send a request and you become administrator. You do it remotely. You don't need user interaction. However, sometimes, say that you want to compromise someone's home router, perhaps the ISP that has been shipped by your home, the router that has been shipped by your ISP, perhaps have some, pretty good default security. So they might be covering the basics. Perhaps there's no internet-facing services, right? So you do a port scan of the router from the internet. There's nothing available. And you say, wow, this is so secure. No one can hack my router. No one can get into my internet. No one can access my router remotely. That's bullshit, because what you do is that you use the trust relationship that the internal user has. Now, some people are against this kind of vulnerabilities. It's bullshit. You need user interaction. I don't like it. It's not lit enough. Well, people get phished all the time. People click on things all the time. People visit web pages. A malicious web page could be anywhere. Maybe you're browsing porn, right? And guess what? In the background, there's been a request sent to your router. This doesn't have to be something noisy. These attacks are simple HTTP requests. Your browser visits a page, something gets loaded, and a HTTP request is sent to your router in the background. And this is an image which I always put in my presentations, and no one laughs, And the reason why I put it is because the first time I saw this picture on the internet, I was laughing for about 10 minutes. I showed it to all my colleagues in my office, and no one found it funny, right? So I guess that I'm the only one who actually finds it funny, because every time I show it to other people, no one laughs. Anyways, that's completely off topic. So why did I say and beyond? I say cracking into embedded devices and beyond. Because I want to send, if there's one idea, one concept I want to transmit, is that sometimes if you compromise an embedded device, you could take things further. So there are several examples that I will give later. But the whole point is that compromising an internet-facing embedded device, which no one cares about, could lead into things such as remote access to other systems that you might actually care about, So for instance, the first potential attack that you could do, say that you compromise this Axis IP camera. It's internet-facing, right? Most people will say, OK, I'm root on the camera. Now I can change parameters. OK, yeah, you can do that. But perhaps you want to use the camera to access the internal network remotely. Now, the assumption is that the camera has not been segmented properly. But experience tells me that a lot of these tiny devices that people don't care much about, they're not usually segmented properly, unlike regular application or web servers. Web servers and application servers, they're always on the DMZ. Everyone is aware of web hacking attacks. For little devices, it's not the case, really. I'm not saying that all companies do not segment these devices, but all I'm saying is that it's more likely that one of these internet-facing little devices will not be segmented. That's all I'm saying. And now, say that you compromise a device, right, an embedded device. There are several things that you can do to take the attack further, right? People that like spending a lot of time on something will probably develop a customized firmware, right? That's really cool, and I think that's great. There's already been some research on the subject. Chaos Computer Club 1 or 2 years ago, there was a proof of concept. That's cool, but sometimes there are easier ways, right? For instance, with Axis IP cameras, you have shell scripting support built in. Axis calls a mesh. It's minimalistic shell. So that means that after you compromise the Axis camera, you can enable the telnet interface by making a configuration change through the web console, right? Then through the web console, again, you can upload files, right? So just upload a file, right? It has like a little file editor. Just put your script there, save it, then log in via telnet, and now you have your own hacking tool. I mean, you can port NICTO to mesh, to minimalistic shell, So if the camera is not segmented, now you're trying to compromise internal web servers through the camera, and this freaking works. I'll show you some script snippets. Axis IP cameras are great after they've been compromised because it's fully open source. You have telnets. The more superior models have PHP support as well. So again, you can do even more fun stuff. very, very stupid script, but it will illustrate the point that you can upload that script and then do URL brute forcing. Get your favorite interesting URLs file from Nicto, your own files, a dictionary file, and start looking for vulnerable CGI scripts, administrator consoles. This is, I have it online anyways, it's public information. It works, it just works, It's a very simple example. As you can see, I'm just using already existing shell scripting, as HTTP client, small HTTP client, it's already on the camera. You have an HTTP client. Why do you have to write something from the scratch, You don't have to. Also, a lot of embedded devices, unlike websites, well, websites will make the same mistake sometimes, but a lot of embedded devices leak passwords and other sensitive information in the source code. So it might, you look at the page, it might look like the password is masked, but it's actually not. You just have a form that says type equals password, which is not really hiding it. It only hides it from your eye. So the idea is, if you compromise an embedded device like a printer, it's a very good idea to, after you steal the password from, say, the HTML source code, to try the same password on other adjacent systems. Because we're all humans, we reuse passwords, When I'm doing penetration testing sessions, I always reuse a password. If I've managed to compromise a password, I will try the same password in every single login interface. I don't care if it's Telnet, I don't care if it's SSH, I don't care if it's terminal services, I don't care if it's VNC, you name it. If you have a service that's asking for a password, you try the same password because people reuse passwords, So that's just another example of how compromising a device might lead you to something more interesting, Perhaps this SSH server for backup reasons, I don't know. Just some examples. There are some implementations that leak passwords through SNMP read access. Some people have told me on the internet, this is bullshit, I've never seen anything like that. You're not ever going to get a password through a SNMP read community string. Well, here are the links. There's 1, 2, 3, 4 links. Go check it out. It's public information. And again, just going by the same philosophy of exploiting features that already exist on the router, or whatever device it is. There is a lot of cool stuff you can do. Here I'm mentioning the example of compromising the video page, hijacking the video. Sometimes you have tools that are for diagnosis reasons, So you might have a ping diagnostic tool. Perhaps you want to write a little Python script or Bash script that wraps around the ping tool. So after you compromise the device, you're basically automating the process of pinging internal IP addresses. So again, you're using an internet-facing device as a proxy to probe the internal network. Those are other examples of how you can bounce your connections through embedded devices. And this is the ping diagnostic tool wrapper. So essentially, you're using, in this case, a Zaxel router as a ping sweeping tool, which will allow you to discover internal host. Zigzag routers, they leak, at least some models, they leak the dynamic DNS password through SNMP, which is enabled by default. So if the administrator is using dynamic DNS, you can go to dynamicdns.com, you log in with the username and password because they're leaked through SNMP, change the IP address it resolves to. Next time the administrator logs in, the password goes to your system, Another example of some things that you might want to try, So, in summary, what are the different things we found, things that I have come across while doing the research? This is a list of them. I will only focus more on some of them because I found some new stuff lately and I want to discuss it as well. I will go through all this stuff now. So these are some favorite things that, after you poke with different vulnerabilities, then you start finding magic combinations, These are some magic combinations. Imagine you have a home router. I like mentioning home routers because we all have home broadband routers, So it's something that we can all relate to, right? Now, most embedded devices, web consoles are vulnerable to cross-site request forgeries, but sometimes this is really kind of like, it's not really that exploitable because you still need the victim has to be authenticated. And if the session has times out, when the request forgery attack happens, the browser will show the password prompt again in order to alert the user that he's about to submit the password again. So it could be a bit noisy. However, say that your broadband router doesn't have any internet-facing services, right? So everything on the one interface is being filtered properly, right? And then you find, say, a request forgery, right? And an authentication bypass. Now what you can do is that through a specially crafted page, now you can make the victim's browser bypass authentication and change things on the router. I will show. This is a real example. Back in the UK, the BT Home Hub is the most popular broadband router. There's about 3 million, between 3 and 4 million at the moment. So some time ago, I was researching it because I had it home, and it's quite a fascinating device. You know, there's a lot of features that you can poke with, and we kept finding vulnerabilities, and then BT will fix them, and then we would find other vulnerabilities, and then British Telecom will fix them again. You know, at least they're fixing them, so it's a good thing. You know. This is, check this out. I mean, if you look at the URLs on the bottom, this is a really, it's the kind of vulnerability that you might, you know, you will probably find through fuzzing. It turns out that if you append some special characters to the URLs, the web server of the router doesn't ask you for a password, you know? I mean, this is like, it's ridiculous, you know? But it works like a charm, you know? If you look at the very bottom, there's a URL, right? And then you see different parameters. If you need to submit different parameters, again, if you look before the question mark, again, I'm putting 2 forward slashes. That's because by appending different characters, the authentication is bypassed. This would give me the authentication bypass. Then if you combine it with a request forgery, you can fully compromise the device. So request forgery, all it means is that the attacker can predict an HTTP request. You know, there's not a dynamic token that makes the HTTP request look different at different times. The attacker can predict it anytime, right? So we developed a really cool exploit, proof of concept exploit. The victim visits a page, say that maybe you're chatting with a victim, I don't know. Hey, check this out, you know, check out this link. This page basically redirects the victim to YouTube and shows the Techno Viking video. I don't know if any of you is familiar with Techno Viking. No? Techno Viking? No? Come on, this is like, it's quite known in Europe. Anyways, check it out, Techno Viking, go to YouTube, it's good. So the victim is redirected to YouTube just to distract him, right? In the background, what's really happening is the following. Check out, notice the action attribute. That's the URL where the parameters are being submitted to. Notice that after RAS, there's 2 forward slashes. So again, we're bypassing the authentication. If you're curious, RAS stands for remote assistance. It turns out that back then, BT had a remote assistance feature. It's kind of like a backdoor for technicians to remotely fix your router. So maybe my grandma doesn't know how to troubleshoot the router. She calls BT, right? And the lady says, okay, what's your, you know, I'm going to log into your router and fix it, you know? It's just, it's a backdoor, but the user has to enable it, right? You need the user's permission. With this exploit, we're enabling the remote assistance feature. And 1, 2, 3, 4, 5, 6, 7, 8 is the password, right? At that point, the attacker can now log in remotely as administrator and do whatever the hell he wants with the router, you know? Perhaps he wants to change, you know, port forwarding rules. Perhaps he wants to expose an internal host to the internet. It's really up to the attacker's imagination. This is just a script that sends an email to the attacker. If you look at exploits in the previous pages, there's just a request that's being sent to a PHP script. The idea is that the attacker is notified when the router has been compromised. So the script will email the IP address of the router and just a silly email saying, look, this router with this IP address has been compromised. This is the URL to log in. Have fun, And this example is really the same thing I showed on the Axis IP camera, It's quite scary how many embedded devices are vulnerable to persistent XSS in the logs page. So if you have one, you might want to check it out, I already discussed this. If you look at the URL in bold, this is one of the, you see edit CGI.cgi? That's a CGI script that allows you on Axis IP cameras to edit any file. So by accessing that URL, and using XML HTTP request, we can scrape that page, so you get a password file, and then you send it to the attacker. Again, if you look at the bottom, bold URL, we send response text to the attacker. Response text is nothing other than this. This is the page that allows you to edit any file. And if you look at the red square, this is, that's the encrypted password of the root account. Now whether or not you can crack it really depends on the password length, but you can see that it's not a good thing that if, there's something wrong. Just because the administrator has checked the logs page, someone shouldn't be able to steal the password file, And of course, authentication bypass, if you have access to a service that's listening on the one interface, it's game over as well. This is more of a peculiar example. Yesterday, unfortunately, I missed the presentation about UPnP IGD. I don't know if you guys have seen it. I researched this topic a lot. UPnP is freaking fun to play with. Play with it. There's no authentication of any type. The only research that I had seen about a year ago, before I was poking with this, is from a website which is quite good. It's called upnphacks.org. And this guy, he was researching UPnP, and he noticed there's some cool stuff he can do. So what we did, his research was based on internal attacks. We wanted to find out if it's possible to hack your router through UPnP remotely. Again, we're back to the same sort of attack. The trick is to make the victim visit a page that will make the browser submit the UPnP request. It's easier said than done because there are certain limitations that you need to bypass. You need to understand, first of all, the request that you're sending to the router is model dependent. Universal Plug and Play has something called description URLs. Basically, the way it works, imagine that you're using Skype, right? You're on your laptop, home network, you run Skype. Skype sends a UPnP request. I think it's msearch. Yeah, msearch, yeah? OK. msearch request, multicast. Hello, is there anyone out there supporting any IGD? IGD in UPnP means Internet Gateway Device. That's your home router. Hello, home router, can you speak UPnP? Yes, sure, I can speak UPnP. These are my description URLs, which means, sorry, or control URLs. I don't remember the right terminology, but basically it's the different URLs which tells other devices or other systems what functionalities the router is offering, right? And this is really how it works. So if you're attacking a router, you need to first of all know what are the control URLs for that model. And there's public demos on how to fingerprint routers based on unique images not existing. If you use new image statements in JavaScript, you can use the onError event. If it gives you an error, it doesn't exist. Otherwise, it exists, so you already know you can fingerprint the router. So don't assume that your router cannot be fingerprinted. You should assume that when you're browsing the web, remote sites can know what's your router. It's a fact. Just live with it. It's just the way it is. So you need to know what's the control URL. And then, most importantly, the challenge is to be able to fake or forge the post request. Now, the post request is not a standard post request. There's a few customized headers. It's a SOAP XML, right? There's a few ways you can forge this request. One of the ways is by finding a vulnerability in the Flash plugin, right? Back then, we found a way to do it with Flash using actually a function that's there for developers. I think it was sent to URL. I'll show you later. So one way is to use Flash, and if you manage to forge any header, it's game over. You can make changes to the router, right, through UPnP. Also, what changes you can make is also dependent on different routers. So don't just think that it's the end of the world. It might be a bit limited, Now, moving on other type of different devices. Some people here might be familiar with Aruba networks. It's quite big in the corporate Wi-Fi world. There was a really cool vulnerability. This was not found by me, but I think it's really cool. So I'm going to include it in the slides because it's quite a good one. There was a persistent cross-site scripting on the login page of the controller. The controller device is in charge of the entire network. So put it this way. If you compromise that device, it's game over in the entire network. It turns out that you can inject anything on the login page, and this is just an example of, overriding the action attribute of the login form. So when the administrator logs in, the password is actually sent somewhere else. And this was confirmed by Aruba Networks, by the way, but no one thought it was that big deal. I don't know. It's really trivially exploitable, so I'm not sure. I love authentication bypass bugs because it means that you can compromise a device without a password, obviously. I'm not going to go through different types. I mean, there's some very peculiar stuff that I've come across. Sometimes even changing the method from get to post will allow you to get a config file without a password. I found that in a BT Voyager router. Again, you know, you play with stuff, sometimes you find things that you just don't even see them coming, you know. Also, if you like VoIP, of course you can manipulate VoIP through VoIP protocols like SIP. But what's really cool is that a lot of these devices, they allow you to make, to perform telephony actions through the HTTP interface. So in the case of the home router, again, we combined the authentication bypass that we found with the request forgery. And if you trick the victim to visit a page, you can make the phone ring. So if you're the victim, right, if you're being fooled, this is what it looks like. Your phone is ringing, right? And it says incoming call. The cool thing is that when you press pick up, you're actually making a phone call. You're actually making a phone call. It's not really incoming call. You're making the phone call, right? To a phone number that has been chosen by the attacker, you know? So I don't know, you could make the phone, I don't know, call the Vatican or, you know, any random phone. Perhaps, you know, in the world of toll fraud, telephone toll fraud, a very common trick for criminals is to register a premium phone number and then use the victim's premises to dial that number, you know? That's how they profit, you know? If you have a PBX in your company, right, and it gets compromised, and they're rerouting calls to a premium number, they're gonna make some good money that way, you know? This is the same story. Another good example in Snomp phones, it's a German company, quite popular in Europe. Mario from GNU Citizen, he found similar vulnerability, but actually more serious in my opinion, because you could make the phone be picked up automatically without the victim really knowing that it's happened. So you're in your office, you have a Snomp phone, and if someone can talk to the HTTP server, which, you know, it might not be available on the internet, but it could be a fellow employee, one of your colleagues, right? So they can make the phone be picked up. You don't even know. Your phone is there, you're talking, and the attacker is listening to your calls. You know, it's just an example of cool things that you can do, you know. It's an eavesdropping attack, obviously. So I've been researching the idea of combining HTTP and other protocols to combine an attack. You know, usually we all stick to the same technology. So if you want to do a web attack, you talk in HTTP, but sometimes you can combine both. Now, with this attack, I'll tell you the counter argument and the pro arguments, right? The idea is, if you have compromised a device via SNMP, so you have cracked the SNMP write community string, right? Usually, you know, if you're a penetration tester, you'll say, it's a high-risk issue, level 4, level 5, game over. In reality, it's not necessarily game over. Sometimes you find that some devices, depending on the implementation, will only allow you to change certain OIDs in SNMP terminology. So only certain objects. So that might mean that even if you have cracked the SNMP write community string, all you can do maybe is change the system name, the contact name, not something that will allow you to fully compromise the device. So if you're stuck in that situation, right, what you can do is use one of those objects that you think that are not a big deal, right, and change it and put a HTML or JavaScript payload. So a common example, if you look at these 3 different OIDs, so we have contact name and location. These are 3 different OIDs that are very commonly printed on the web interface. Remember, you have write access through SNMP, but you're limited. You can only change certain OIDs. Now you need to sneak your payload through SNMP on the web console. So next time the administrator logs in, boom, you compromise the device, right? So that's the idea. So you can think of it as a privilege escalation attack, really. Cisco routers, most of the Cisco routers are vulnerable to this. Again, remember that you need to find the SNMP write community string. But you can go from a restricted situation to a full compromise. It's been confirmed by Cisco, right? They checked it. It works on most of the devices. The reason for that is because the Cisco iOS HTTP server prints the system name in virtually all pages. If you have a Cisco router, just notice that you usually have the system name printed on the top left corner, I think, of the web interface. So if you change the system name and you put a malicious payload, there's a really, really high chance that the payload will be triggered, provided that the administrator logs in on the web console, because it's printed on every single page, you know? So this is just a screenshot. It's cropped, obviously, you don't have everything else. So what's wrong with this picture? Well, there's an image on the top left corner. That image is actually making it's not a real image. It's just an image tag which makes the browser submit a HTTP request to the router, which changes the password. Now, there's a way to inject an image without showing, right? You can use JavaScript and dynamically generate an image. So please don't think that if something is injected, it will be obvious, because you can make it completely invisible. I use this method because it's better to illustrate that there's something being injected. This is the HTTP request that it's actually sent in the background. So it's basically changing the enabled password. So again, at that point, the attacker can log in with that password because it's been changed. This is command execution, okay? It's really, for me, I think it's quite cool. It's been confirmed by Cisco, and as a researcher, there's nothing more gratifying than someone finding your research interesting. So the Cisco PSIRT team, they said, we read your paper and we found it interesting. It is by far the most creative approach we've seen so far for an XSS attack against the iOS HTTP server component. I thought it wasn't that cool. They liked it a lot, so you know, it helped me boost my ego, and then I'm back to reality. Go back to work, keep doing your boring stuff. You know, that was the highlights of the day. Someone liked something that you've done. Whoa, cool. Okay. Now, firewalls are there to protect you, but you know, in security research, we know that security mechanisms sometimes actually introduce security problems. We see in the world of antivirus all the time. There's so many guys like exploiting the drivers, right? Because the antivirus runs with system privileges. You know that if you exploit it, it's game over. Not only your administrator, your system, it's even better, you know? That's because the antivirus runs with those privileges, obviously. I was playing with Sonic Wall firewalls, right? And you know, if you work for a big company, right? If you work for a big company, you'll see that they usually have content filtering. And that's really annoying because it means that you might not be able to check your personal webmail. Most importantly, you cannot browse porn on the internet and all this kind of like annoying stuff, right? Now, what's really funny is that it turns out that you can exploit the content filtering service to hijack any website. So I'm going to go through the example, right? So say Sonic Wall, right? Firewalls, like many other firewalls, they allow administrators to block pages by category. So the service will update on a regular basis, and it will say, okay, this is the updated database for hacking sites. This is the updated database for pornographic sites, right? But it will also allow you to block sites based on keywords. So if you go to Google and you search for, I don't know, choose your favorite swear word, the URL will, you know, HTTP request will have the keyword, and the content filtering service will say, hey, this is a bad word, not allowed. Well, this is the actual feature precisely that I'm exploiting in Sonic Wall. So you get a page. I will show you, actually. You get a page, right? And it says, sorry, you know, this page has been blocked by the content filtering system. Now, notice the following. This is very, very important to understand the implications, the security implications. If you look at the address bar, it says google.com. In reality, google.com has not replied to my HTTP request. It's the firewall. The firewall is sitting between you and the internet, right? Now, this is really funny because usually when you're compromised, it's because there's either a problem on your side, so the client endpoint, so there's a vulnerability on your browser or browser plugin, operating system, or maybe there's a vulnerability on the server that you're connecting to. Imagine, maybe you're going to YouTube, right? YouTube is a bad example, okay? But let's say that someone compromises a website that you use often, right? The attacker has exploited a vulnerability on the server. In this case, it's something in between. It's not you, it's not either endpoint, it's not the user, it's not the site you're connecting to. You have an intermediate appliance, a hub in between, right? And that appliance is there to protect you, but actually it's not, it's allowing the attacker to hijack any domain. So what's important is, if you look at the URL on the top, we have a swear word, it says fuck. I'm sorry to have to include a swear word, but I had to because it's the only way to make this work, right? So excuse my language, sorry. I wanted to blur it, but then if you blur it, then people don't know why it works, you know? It works because it's a keyword that's under swear words, and it's been blocked. Google.com, because that's the URL that has been requested. And then you have basically the scripting code that runs within the context of Google.com. That's the most important bit. So it means that, you know, as any cross-domain vulnerability, you can hijack anything from that domain. You can scrape any page, perhaps your address book of Gmail. You can, I don't know, steal your cookie. You can inject fake HTML. And if you're into cross-site scripting, it's DOM-based cross-site scripting, which is perhaps the most misunderstood type of cross-site scripting. Amit Klein wrote a paper a few years ago, and he clearly said, I have not come up with this vector, but I'm making a distinction between regular XSS, persistent XSS, and this third type. And he's quite right. You know, there's a distinction. Typically, when you have XSS, the payload is being returned by the server. So you have a specially crafted payload, you inject it, and the server returns it back. In this case, it's not going to work. So if you're running your favorite vulnerability scanner, most likely it's not going to pick it up because the error page is not returning the payload. It's using DOM functions. In this case, it's using document.write. And if you notice, on the very top, what's really actually writing is document.url. That's basically the URL in the address bar of the browser. You have full control over that. So put it this way. If you have a Sonic Wall firewall in your company, and you have content filtering service enabled, most likely, if any of your employees is tricked to visit a page, you know, any website on the internet can be scraped. You know, any of your personal data can be stolen, or cookies. It's been confirmed by Sonic Wall. I submitted the vulnerability through ZDI, and it was quite cool because zero-day initiative usually is more about memory corruption bugs, you know. And this didn't fit into that category. It wasn't a heap overflow or something like that. But they thought that the vulnerability is quite weird, so it's, you know, they thought, yeah, it's cool. We like it, you know, we're interested in it. And for some, in some browsers, if you put the payload after, you know, directly in the URL without doing anything tricky, it won't execute it. In the case of Internet Explorer, you need to put it after the hash sign. Otherwise, the payload won't execute. So it could be tricky to make it work on all browsers, but I proved that I could make it work on IE 6 and 7, which are pretty much the most popular browsers. So that's enough for me, you know. And you know, the whole idea is, you know, we know about vulnerability types, but sometimes there are weird ways. You know, these vulnerabilities can be found in interesting services. You know, in this case, so far I haven't seen a vulnerability on a firewall error page that allows you to hijack any domain, you know. It's kind of like similar to the Adobe Reader Universal XSS, but actually in this case the vulnerability is beyond your control because you don't have control over the firewall. Updating your operating system is not going to help you. Updating Internet Explorer is not going to help you. The only thing that's going to help you is having a non-vulnerable firewall, you know. And again, going back to home routers, a lot of home routers now, they come with encryption enabled by default, you know. But it turns out that many of these default encryption keys, they're predictable, you know. So if you buy a home router and it comes with whatever encryption type, you know, the WPA, whatever it is, just change the default key because there's been already like quite a few examples, you know, at least 4 examples as in May 2008. So, and actually I've seen at least two other examples. There's been a lot of examples in which, you know, people have figured out that actually the keys, they're predictable, you know, and usually they're derived from either the SSID or the MAC address of the access point, which are both public information, even if the network is encrypted, you know. Even if you disable SSID broadcasting, all the clients, all the stations are going to send a probe request, you know. So the clients are leaking that information anyways. You cannot hide the SSID, you know. MAC address, same thing. Even if there's encryption, you're still going to be able to get the MAC address. That's not encrypted. So quite cool stuff. That was published by Kevin Devin. He likes playing with, you know, reverse engineering and all this kind of stuff. But he was really clever, in my opinion. He did a really, really clever, he approached the problem in a clever way. So let's say that you want to find the algorithm to generate the default key, right? what most people do is that they go for the router itself, They try to do remote debugging through GDB, They try to dissect the firmware. But this guy was more clever, man, because what he did is he, first of all, found another ISP in Europe using a similar router, because the BT Home Hub, it's actually a Thomson speed touch router. It turns out that in Spain, Orange would provide a CD with the speed touch routers. And this CD basically allows you to automate the process of configuring the router. We all seen the CDs. And the setup process included setting up the encryption on your workstation. So what he did, he said, I don't care about the router. Who cares? I have a piece of software here which has the algorithm built in, because the wizard on the CD would actually automate the process of configuring the encryption key on your system. So the software must know the algorithm. So he just basically reverse engineered the wizard, and off you go. He figured out how it's predicted. So for me, what he did is clever. He found the way forward in a non-conventional way. Most of us would have just targeted the router directly, I think. I don't know. And there's public tools for most of these attacks. Once you can predict the keys, we know it's game over. Also, I already stopped playing with the BT Home Hub back in the UK, because I changed to cable, and so now I don't have really access to one of them. But every time we would release a vulnerability, BT would fix it. And eventually, it started getting really, really locked down, But BT now wanted to make it so secure, which is a good thing, that they even said, now we're not going to have the default admin password, because they were aware that people could potentially forge a request, including the default password, right? So they said, OK, now we're going to change the default password to a unique value. That's really good. So now the password is completely different on each router. So we already know that you can break in via Wi-Fi, because the keys are predictable. And actually, older versions of the router, they use web, which we know that it can be cracked in a few minutes using the right tools. So let's say that you break into the wireless. Now you want to compromise the router. That's the second thing. However, BT now, after the latest upgrade, it caused the router to change to a weird password, which is completely non-crackable, right? Again, if you start playing with things, you learn about technologies, you learn about protocols, and there are things out there that will eventually give you the information you need. In this case, there's a protocol called MDAP, which is a Thomson proprietary protocol, which is used for firmware upgrades. And that protocol will give you the serial number of the router, which turns out to be the admin password, which the routers have been changed to. So BT decided to make the password unique, and actually the password was the serial number. But it turns out that you can send a multicast request to the network, right, and get the serial number with MDAP protocol. And yes, you have to be associated to the network, so you cannot do it over the internet. Well, I haven't found a way. But in this context, we're talking about someone that breaks into the network wirelessly, and then he wants to compromise the router. But the password is not predictable. Well, actually, yes, it is predictable, because the MDAP protocol gives it away. And that's just, again, a couple of scripts. I put them online as well. It's nothing special, This is nothing else than you playing with things, researching protocols, and just having a go. This is finally some thoughts, for all of us, as broadband users. A lot of ISPs now, they're giving free routers, right? And that's just to keep you happy, so you sign for the contract, and it's a way to increase revenue, right? They're combining a lot of services into the same router. So now they're giving video on demand, VoIP, internet access, of course, everything's under one box. But there's already been some discussions in the news about some major ISPs actually collecting your customer data and sending it to third-party companies, right? Of course, they call it customer analytics. We call it spyware, because it's really spying on your behavior. I mean, you don't really know what's being sent, So check this out. Now we have, like, if it wasn't enough with our own computers, now we also have to worry about our home routers being backdoored, right? Having non-legitimate features which have actually been introduced by the ISP. So the attacker is not necessarily a teenager playing with your router. It could be your ISP, So there's some really cool toys that can be bought on the internet. If any of you guys ever buy this, please let me know, because with this toy you can sit between your telephone jack and your wall jack, so it's gonna allow you to debug the entire connection, all the traffic. So that means that now if your router is doing anything dodgy, right, you can find out what's happening. Also for vulnerability research purposes, a lot of these routers, they're now being upgraded remotely, automatically by the ISP, right? So now you have to question, you have to wonder, first of all, questions. Okay, how is it being done? What kind of technology is it being, it's being used? Is there encryption, Do you need a password to upgrade it? Can only certain IP addresses upgrade your router? Because if it's not the case, that means that after you debug the traffic, you can start upgrading anyone else's router, on the internet. So there's some really, I think that buying this toy would lead you to find things, put it this way. I'm not sure how much it cost. I sent an email some time ago, and the company never replied. So maybe they thought I wasn't serious. I'm not sure, but I did it in a very serious way, formally, as a researcher. They never replied. And final thoughts, if you guys, it's an area that there's not a lot of research being done, so it's actually more likely that you will find interesting things because not a lot of people are playing with it. If you play with the kind of stuff everyone else is playing with, then it becomes harder because everyone is just, finding the holes, So I don't know, I think it's quite cool to play with little toys, all of us have a broadband router. Take a look at it. There's a lot of vectors, SNMP, universal plug and play. I mean, there's a lot of cool stuff that you can do. And if you like IP cameras, as I said, the Axis IP cameras, they're very cheap on eBay. Open source, they have an SDK. There's a developer wiki site on axis.com. So if you want to write your own proxy, that'd be really cool, because now you upload the proxy, you compile it, right? And now the camera is basically a proxy, right? Say SOX proxy. Run your favorite pen testing tool. Go to the configuration settings and set the proxy to be the camera. And now you're like scanning the internal network via the camera, I mean, most pen testing tools, they allow proxy support, So if you can either write a proxy or port it for Axis IP cameras, that would be really, really cool. It's just some ideas, And I know it's late, so thank you very much for your time, I know it could be a pain sometimes, so I really appreciate your attention, Thank you very much. So is there any questions? Please don't be shy, Even if you didn't get anything of what I said, I don't care. Just ask me. I don't care. I mean, just ask me. Maybe there's some weird idea that you have, No? No questions? Come on, there must be something, no?
Is there any way, basically, to check whether it is vulnerable without, is there a way? Some manufacturers may actually patch their web servers on the embedded devices.
They do. Usually, if you find a vulnerability and you make it public, they do sometimes. But I've seen some embedded devices that are running really old embedded web servers that have been found to be vulnerable. So something tells me that you need to bring it to their attention, because there's some vulnerable versions of, say, HTTPD daemon, right? Light HTTPD, sorry. And if, say that the latest version is 10, you go to an embedded device, update it, and the latest version of the web server is actually 8, for instance, So they're not always upgraded, They're not always up to date with the current public release of the web server. It's another problem because, these devices don't get updated on a regular basis. Just people don't care about them,
It is used, actually.
Yeah, Axis is they're quite popular, yeah. Okay, I think I have to go because I'm taking your time and I'm really sorry. Hey. And actually, I have to go to another room now. Oh, true, the coffee break. Oh, good. Yeah, because I know it's quite frustrating sometimes,
Scary stuff. This is my server room.